Hello everyone, here we are going to continue with exercise 17b of the chapter circles. We have already did till question number 5 in our previous video. Now we'll be doing question number 6. Now here in question number 6 we are having this figure in which we have to prove the triangle OPA is congruent to triangle OQC, that is triangle OPA. So for that we are going to join this one with A and this with Q. And we have to prove this triangle OPA is congruent triangle OQC. And to prove this one, we have been given that this OQ will be equals to OP at the radius of the same circle. Then we can take this OC equals to OA at the sides of the square and this angle as common in both of the triangle. Now let's take the triangle OPA and triangle OQC. Now here in triangle OPA and triangle OQC, we are having OP equals to OQ as these two are the radius of the same circle. Then OA equals to OC at the sides of the square and this angle O common in both of the triangle. Now to prove these triangles congruent, we have used this side, this angle and this side. So it is SAS. And therefore we have got the triangle OPA is congruent triangle OQC by SAS. And this is our first part. Now we'll moving for the second one, BPC and BQA. So BPC, that is we have got this triangle, and BQA, that is this one. So we are going to prove these two triangles congruent. In this one, we have got this side equals to this one as the sides of the square. We can take this angle equals to this angle as the vertex angle of square, and we need the third side. Now the third side can be proved this CP equals to QA, but उसके लिए हमें थोड़ी सी working करनी होगी, that is this OC equals to OA at the sides of the square and this OP equals to OQ at the radius of the same circle. और अगर हम इस पूरे में से इसको subtract कर दें, then you will be getting this one equals to this one, क्योंकि इसमें भी ये पूरे में से इसको हम equally subtract कर सकते हैं. And here we get OC equals to OA at the sides of the square, then OP equals to OQ at the radius of the same circle. Then on subtracting these two, OC minus OP equals to OA minus OQ, that will give you CP equals to AQ. Now in triangle BPC and triangle BQA, and here we get in triangle BPC and BQA, CP equals to AQ, that is proved above over here, and BC equals to BA as the sides of the square, and angle BCP equals to angle BAQ as 90 degree each. Now to prove these two triangles congruent, we have used this side and this angle. So it is SAS. Therefore triangle BPC is congruent to triangle BQA by SAS. Hence proved. Now let's move to question number 7. Here in this question, by the information given in the question, we are having this figure in which we are having two circles and this AB is common chord of both of the circle, and the length of this AB is 30 centimeter. Then we have been given the greater circle or the larger circle is of 50 centimeter diameter. This means the radius of the greater circle is 25 centimeter, and then the smaller circle is having a diameter of 34 centimeter. This means this will be having a radius of 17 centimeter. Now we have to find the distance between the centers of these two circles. Before we start the question, I would like to tell you one thing, that the line joining the two centers is the perpendicular bisector of the common chord. This means अगर ये पूरे का लेंथ 30 सेंटीमीटर है तो ये M से यानी AM is equals to BM and this will be of 15 centimeter और यहाँ पर एक 90 degree angle भी होगा. So here, as line joining the centers of the two intersecting circle is perpendicular bisector of the common chord, therefore this OP is perpendicular to AB and AM is of 15 centimeter. Now we have to find the distance of this OP. So as we see that we are having 15 centimeter over here, this one is 25 centimeter, and we are having a 90 degree angle over here. So we can use the Pythagoras theorem to find the length of OM in triangle AOM. So in triangle OAM, by Pythagoras theorem, we get OA square equals to OM square plus AM square. Now we are having the value of OA, that is 25 square, equals to OM we have to calculate, plus AM we are having 15 square. Now this will be written as OM square equals to 25 square minus 15 square, and this is 625 minus 225, and this will be 400, and this OM will be equals to the square root of 400, and that is equals to 20 centimeter. Now here we have got the value of OM. Now similarly in triangle AMP by Pythagoras theorem we can calculate the value of PM. So in triangle PAM by Pythagoras theorem we get AP square equals to MP square plus AM square. Now here we get the value of AP, that is 17. So 17 square equals to MP we have to calculate. So MP square plus AM we have got 15. So this is 15 square. And on rearranging this will be MP square equals to 17 square minus 15 square, that is 289 minus 225, that is equals to 64, and MP equals to the square root of 64, that is 8 centimeter. Now we have to find the length of OP. So OP equals to OM plus MP, and here we have got the value of OM as 20 centimeter. So we can write 20 over here, and this one is 8. So we've got final answer as 28 centimeter. Now let's do question number 8. Here in this question, by the information given in the question, we have got this figure in which we are having two chords AB and CD, और इन दोनों chords के mid points को जो line join करती है वो center से pass कर रही है. Now we have to prove these two chords are also parallel to each other. So very first of all, we are being given that the two chords are having the midpoints at P and Q, and they both are passing through O. Now as the line joining the midpoints of the chord to the center is perpendicular to the chord, therefore this OP is perpendicular to AB and this OQ is perpendicular to CD. So we can take, there's a 90-degree angle over here as well as over here. Now question में हमें already given है that POQ is a straight line, as it is saying the line joining the midpoints of the chord passing through the center. This means POQ are straight line. Now as we see that this is 90-degree and here this one is 90-degree, and they both are also interior alternate angles, therefore this can be proved as parallel to CD. So very first of all we can write POQ is a straight line which is given in the question, and angle QPA will be equals to angle PQD, 90-degree each. Now as they both are also interior alternate angles, therefore this AB will be parallel to CD. And here we got these are also interior alternate angles, therefore this AB is parallel to CD, hence proved. Now let's move to question number 9. Here in the question we have been given with this figure in which ABCD is a straight line and is perpendicular to PQ, where P and Q are the centers of the respective circles. Now we have to prove this AB equals to CD and AC equals to BD. Now very first of all we are going to take this one as O. Now we know the perpendicular from the center bisects the chord, therefore this BO will be equals to CO. So here we get BO equals to CO as perpendicular from the center bisects the chord. Now in the bigger circle also, the perpendicular from the center will bisect the chord, and this AO will become equals to DO. And here we get AO equals to DO. Now let this one be equation number 1 and this one be equation number 2. And if I subtract the equation number 1 from equation number 2, we get AO minus BO equals to DO minus CO. Now AO minus BO will be equals to AB and DO minus CO will become CD. This is our first part to be proved. Now to prove the second part, we are going to add this common portion BC in both the sides. Now adding BC on both the sides, we get AB plus BC equals to CD plus BC. And AB plus BC will become AC and CD plus BC will become BD. Hence proved. Now let's move to question number 10. Here in this question we are having this figure as the information given in the question. In this we have been given with the two equal chords, that is AB and CD, and they both are perpendicular at point P. They intersect at a 90-degree and are perpendicular to each other. Now इसमें O एक सेंटर है और जहां से दो परपेंडिकुलर और यहाँ पे ड्रॉप किए गए हैं, दैट इज OM ऑन द कॉर्ड AB एंड ON ऑन द कॉर्ड CD। नाउ हमें ये प्रूव करना है कि ये जो फिगर बन रहा है यहाँ पे, दैट इज OMPN इज अ स्क्वायर। नाउ वी कैन सी दैट वी आर हैविंग 3 राइट एंगल इन दिस क्वाड्रिलेटरल। अगर इसमें 3 राइट एंगल्स हैं तो चौथा तो अपने आप ही राइट एंगल हो जाएगा। एंड इफ इट इज हैविंग द 4 राइट एंगल इन द क्वाड्रिलेटरल, दिस मींस इट इज अ रेक्टेंगल। अब रेक्टेंगल की प्रॉपर्टी को स्क्वायर में कन्वर्ट करने के लिए वी हैव टू जस्ट प्रूव वन थिंग, दैट इज दिस साइड इज इक्वल टू दिस वन, that is two adjacent sides are of equal length. So for that we have to join this line O with a P, and we are going to prove the triangle ONP congruent to triangle OMP. Now in triangle ONP and triangle OMP we are having ON equals to OM as equal chords are equidistant from the center, and OP is common in both of the triangle, and this angle ONP is equals to angle OMP as they both are of 90 degree. Now to prove these two triangles congruent, we have used this angle, this side and this side. Therefore, the both triangles are congruent by using RHS. So here, both of the triangles are congruent by RHS congruency criteria. And then we have proved this NP is equals to MP as the by CPCT. अब इस कोऑर्डिनेटर में अगर हम देखें तो यहाँ पर ये एंगल और ये एंगल, ये तीनों ही 90 डिग्री के हैं। दिस मींस दिस कैन बी अ रेक्टेंगल और अ स्क्वायर, क्योंकि एक स्क्वायर और रेक्टेंगल में ही तीन एंगल 90 डिग्री के हो सकते हैं। बट हियर वी हैव आल्सो प्रूव्ड दिस एनपी इज इक्वल्स टू एमपी, मतलब दो एडिसेंट साइड्स भी इक्वल हो गए। अगर दो एडिसेंट साइड्स इक्वल हैं, दिस मींस इट विल नॉट बी अ रेक्टेंगल, इट विल बी स्क्वायर ओनली। सो हियर as three vertex angles of a quadrilateral is 90 degree and two adjacent sides are equal. Therefore, OMPN is a square. That's all for this video. Thank you.